Good afternoon, everyone. I'd like to welcome you to today's webinar on artificial intelligence, machine learning, challenges and opportunities in DoD adoption, focusing on AML pricing, and we're very excited to have an incredible panel of government and industry leaders to discuss these issues. One of the things about AI and ML is that it's definitely not a buzzword. I mean, I sort of define a buzzword as something that's sort of talked about and overdetermined. The reason why I say that is government agencies are buying artificial intelligence capabilities now. And that is growing exponentially. And some of the companies that are here as on the panel and in the audience, represent that that community. And buyers like Ryan Connell from DCMA and other government folks that are also on this call are some of the customers that are trying to figure out how to buy it. It's not exactly like software, and it's definitely not exactly like hardware. So how do you do that? So that's what with the conversation. We're very excited to host that here for you all. And but to set the table for us, I'm very honored to have Sharon Hayes, Dr. Sharon Hayes from LMI. She's the Chief Strategy and Technology Officer for LMI, which LMI is a company which has burst onto the scene in the last several years, growing exponentially, which is interesting for a 60-year-old company almost, but they've doing tremendous work in artificial intelligence and other digital engineering and other areas. So they're very focused on this topic. So Sharon is her background is she has a bachelor's in molecular biology from UC Berkeley and a doctorate in biochemistry from Stanford. But she's also worked on the Hill and in the Office of Science and Technology Policy before coming to industry. And before joining LMI, she was a vice president at General Dynamics Information Technology. So to kick us off, I want to turn it over to Sharon. Really excited to have you for this discussion.
Well, thanks so much, Jerry. It's my honor to be here and to have the opportunity to co-sponsor this this panel discussion, which I'm really excited to listen in on. You know, you mentioned we've been around for 60 years. LMI started as a not-for-profit, and we are still owned by a parent not-for-profit company. But our mission has always been to help the government solve its most challenging problems. And we do that really as, really started as a company of consultants. But we have moved, and perhaps the reason, Jerry, that you sort of see us as bursting onto the scene in the last couple of years is we've moved more and more to integrating our strong consulting capabilities across a really wide variety of different problem areas for the government. I mean, everything from energy security to project management to HR to acquisition within the Defense Department. I mean, it's a really wide range of capabilities, but marrying that up with digital capabilities. And of course, the hot topic today is artificial intelligence, machine learning, and we have an active practice in those areas. So, you know, I know that the panel is going to tackle a number of the challenges that exist right now, particularly in terms of pricing AI ML and how the government buys it, with an emphasis on DoD, although it's not just a DoD problem, obviously, but you know, those problems really are going to be really a lot of light is shown on those problems by exactly the kind of speakers that you're going to hear from today on the panel. You know, hearing from the software industry, hearing from people with experience in hardware, hearing from folks that are actually running AI companies, all really important, as is, of course, the government perspective. So we sit more at that intersection of services and digital capabilities. And I think that's going to be such an important part of this conversation. How do you bring those two different groups together to actually solve the problems that AI and ML can solve? Because it's not a magic bullet, and it really depends on having the subject matter experts and the digital experts in the room together, talking together and understanding the true nature of the problems. So that's one thing I'm really anxious to hear this panel talk about. And the other, it's been mentioned before in the read ahead that some of you may have seen on the panel discussion. There's the bright shiny object syndrome going on with AI and ML right now, right? You can buy it and it's going to solve all your problems and it's going to be a miracle. And we all know, I think everyone probably that's listening knows that's not the case. But how we deal with that perception is a challenge in and of itself. So I will turn it back over to you, Jerry, so we can get on with the great panel discussion that we're going to hear today.
Great. Thanks, Sharon. I think you really did set the table for us. And again, thank you to you and to LMI for sponsoring this great event. And I'm pleased to introduce Ellen Chang. Ellen Chang is our partner in crime on this event. We're very pleased to do co-brand this event with Wharton Aerospace. It's a tremendous East and West Coast organization that does events focused around of interest to the aerospace defense community. And Ellen Chang is one of the co-founders and managing partners of Wharton Aerospace. So over to you, Ellen.
Thank you, Jerry. And I see that Michael Langman's on, the other half.
Yeah,
of
that's right.
Other half.
So, excellent.
Yeah, so thanks for having us. And I'm super excited to talk about this topic. Let me just provide you a little bit of introduction to myself as well as the topic. So Wharton Aerospace founded, 15 years ago now, and we host key conversations with the industry. Several of you in the audience might actually know our annual conferences. And then there's a couple of groups, one in Philadelphia, a little bit more traditionally minded, and then I'm over here in the West Coast and have often focused on emerging technologies and ventures. And I have a background in not just government contracting, but also kind of venture investments. And in prepping, the reason why this topic actually surfaced was because Andreessen Horowitz, one of the Palo Alto-based venture capital firms, had written on the unit economics of artificial intelligence back in 2020, spurring a bunch of conversation or heated conversation around, the fact that AI companies are different, or so they assert, different than traditional software companies. Software seemingly being more scalable because AI invariably involves data. Sometimes the data is not clean, so you have to clean the data. You have to then develop models. You might not have data to train the models, and then you have to validate the models, et cetera, et cetera. I'm not an AI specialist, so I'm not going to, put foot in mouth from that perspective. And but suffice it to say, there was a lot of discussion around whether it's scalability, it's unit economics. And then I was talking to Eric Lofgren, who is a senior fellow with Jerry McGinn's organization, Center of Government Contracting, and we were talking about the pricing aspects of it, and the fact that the government has a hard enough time getting its arms wrapped around software. How is it dealing with pricing with AI types of systems? And so I just want to, we've invited 3 different individuals or companies to talk about that, since they do have experience here. So what I'm going to do is have each of the panelists introduce themselves, as well as their organization, and to be able to set the foundation from which to then have further conversations on this topic. So Sheldon, I'll start with you. How about introducing yourself as well as Darwin AI and what you're doing in the space?
Absolutely, and thank you for having me, and thanks for all our attendees for joining us today. So Sheldon Fernandez, CEO of Darwin AI. We are a 4-year-old artificial intelligence company, actually based out of Canada, Toronto, Canada. We are organically connected to the University of Waterloo, which is kind of like the MIT of Canada. And we've been working in aerospace and defense really since our inception, collaborations with Lockheed Martin, with Honeywell Aerospace. And we essentially have technology that illuminates the black box of artificial intelligence. So you'll often hear that one of the challenges of AI is that it can do all these wonderful things, but even the people that design it don't really understand why it's doing what it's doing. And so based on years of scholarship from our academic team, we can, explain how that is actually unfolding, which has important implications for transparency and trust. and which, needless to say, in the context of what we're talking about, is very important. So looking forward to the conversation today and, hearing from my fellow panelists as well.
Okay, yeah, thank you, Sheldon. Craig, how about you and algorithmia? You have to come off mute.
Yeah, classic Zoom error right off the top there. There we go. Hey, it's Craig Perrin with Algorithmia. It's a pleasure to be on the panel today. Thanks for having us. We're a provider of machine learning operations platforms that are used to put models into production. And we have experience in commercializing and operationalizing AI and ML in both the federal and commercial spaces.
Diego, do you want to amplify?
Great. Yeah. So Craig here runs the federal practice for us. So he's the expert on this side. I'm the CEO and founder of Algorithmia, and as he mentioned, we've been working with DoD and partners in the aerospace and manufacturing for a long time now. And again, it's around how do you we have a software platform that enables getting from models from kind of the research lab into like production operational systems and accelerating that.
Gotcha. Thank you. And Ryan, please introduce yourself and your organization.
Sure. Came off mute, so I don't pull a Craig here. My name is Ryan Connell. I work for DCMA's Commercial Item Group. So DCMA is the Defense Contract Management Agency. This team that I work for was stood up in 2000. Kind of came out of the 2013 NDAA. Officially became operational in 2016. Really, our mission is to help Army, Air Force, Navy. They come to us. We're almost like an organic consultancy. So when they're having questions regarding buying commercial tech products or services, they come to us. We help with some of their contracting paths forwards, and then what a fair and reasonable price to pay is for what we're buying. And so excited for the conversation today. From an AI perspective, for us, it's been a little theoretical so far. And I mean, same with software, but excited to sort of put some theory to practice, and excited to be on the panel with everyone.
Yeah, that's really good background, really good to know. It'll be interesting to probably have Sheldon and Craig and Diego talk about it, and then get your perspective, Ryan, because I think as it's from the DCMA perspective, you're almost doing some quality assurance around, how the contracts are actually being executed. So Sheldon, I'm going to start with you. You call yourself an explainable AI company, and I don't know if that means even more maybe manual labor content within what you do, but could you just talk through maybe the workflow and why do you agree with the assertion that AI companies are different than software, and help us understand a little bit more about how you go about your business?
Absolutely. So first of all, I would agree that artificial intelligence companies and the workflow is different. And maybe just to clarify, when we talk about artificial intelligence today, we're generally talking about machine learning, the second wave of artificial intelligence, as it were. And the crux of machine learning is that we are asking a machine to intuit behavior based on looking at tremendous amounts of data, which is different from classical software that was programmed by a human being and works in a very mathematical, predictable kind of manner. The example I often give is, I have a 2.5-year-old who now can recognize, animals, and he'll understand what a lion is. He'll understand what a cat is. And we don't really understand how the human mind does that. All we know is that about 20 years ago, it was tremendously difficult from a theoretical computer science point of view to get a machine to do this. But of course, what changed was the theory of machine learning, which became popular in the 90s, really got the data and the computational power to bring it to fruition. And so now, to get a machine to recognize a lion, we give it, hundreds of thousands, if not millions, examples of a lion, and using, the theoretical underpinnings of machine learning, it'll become extremely good at that task. The challenge is that we don't necessarily know how it's reached that understanding. We don't necessarily understand why it thinks this is a picture of a lion and why it thinks this is a picture of a hamburger. To anchor this in a very practical way, we had an autonomous vehicle client, so in a slightly different space, run into a very strange situation where their car would turn left with increasing statistical frequency when the color of the sky was a certain shade of purple. And of course, we as human beings know that makes absolutely no sense, but that's what it was doing. And so we basically helped them determine that they had trained the system in the Nevada desert when the color of the sky was this shade of purple, and that's the correlation it had made, right? So the challenge with explainability of this black box problem is if you don't know how something works, you don't know when it'll fail. And if you don't know when it'll fail, there are all these exceptions lurking in the system waiting to manifest themselves with potentially disastrous consequences. And so if you think about that contrast compared to classical software, a lot of the discussion goes around the data that you collect. Is it biased in some way? There's a tremendous amount of effort that is spent there because a machine learning system is giving you insights, not about the real world, but about the data. And then we talk about, having a machine learning system in some way being deployed out into the wild when it's non-deterministic, meaning we don't completely understand how it will work. And so what does that mean from a testing standpoint, a workflow standpoint, a governance standpoint? And all that behavior has important implications for how we think about AI, for how we develop against it, and of course, for the economics behind it. So I'll pause there because I'm sure my fellow panelists have stuff to add, but that's the crux of the challenge we're dealing with and trying to solve for the enterprise, including defense.
Well said. I'm going to invite Craig then, given your position at Algorithmia, and understanding federal contracts. And I imagine you can talk to Algorithmia's offering and how similar it is to what Sheldon described, but also perhaps based on your background, how have you negotiated with the federal government, I guess, in terms of the contracts you have, what works and what doesn't work?
Yeah, well, for Algorithmia, it's easy. We're lucky. We provide infrastructure that runs the models and the AI, and we get to watch our partners and our competitors and others, or the model builders of the world, have to deal with the complexity of doing business with the government on their IP. And it's very challenging for especially small businesses that may have innovative approaches to deploying AI and machine learning models, or building those models, in that, you can go pursue a bunch of research and R&D money, for example, from the feds. And that's a real clear, path to get funding to kind of build out your ideas and your products. But you have an intellectual property risk, or intellectual property sharing requirements that come out of those things that sometimes make that hard for small companies to do. Flip over to the traditional way of buying software. Government buys systems. It buys things like Titan and bases and products and trucks and stuff like that, which are going to be powered by AI or use AI to do that. But how do you have to address this question of how do you embed your AI powered resources within that kind of system? And so there are challenges, for how companies buy AI. The kind of the ideal that we talk about a lot is getting it to where you can buy AI by the drink, right? If you think about what people want out of machine learning, out of AI, it's not necessarily all the guts and the software and the models and the training and all the things that goes into it, but it's the inference, it's the output. You want to, the purpose of using an AI, if you're in the Treasury Department to find fraudsters and money launderers, it's not to play with software, it's to find the fraudster, right? And so some sort of mechanism by which you can pay for the results, I think is a needed innovation. And I'm not quite sure, what's the right way to get to it, but I do think it will help spur investment in AI if there's a way to do that.
Pay for results. Okay, so that's an interesting approach. Would I guess I'll throw this out there? Would companies, and maybe it's only the leading edge companies might invest that time to commit themselves to results, because there could be so many different perspectives on whether or not something's a good result or not. I could see risk there. Like how do you propose getting over that hump?
Yeah, definitely not a clean path forward in terms of procurement, right? I think it's, if you use the concept of a marketplace that says, hey, if you're a technology company, you can bring your IP to this federal marketplace. Agencies may not use it, may decide to deploy it, have a way of monetizing the use of the technology itself versus the acquisition of the software. There's a way to do it using that kind of marketplace concept. I don't know if if the FAR is ready to roll with that, or if contracting mechanisms are in place that will allow that to happen. And
maybe that we turn that over to Ryan. What are your perspectives then? I'm not exactly sure how DCMA would get kind of involved with all of that, but what are your perspectives?
Yeah, so just Ryan's thoughts on this, right? I mean, I think everyone's kind of hit on it already. We don't really know yet, right? And so what we do know is valuation of software products. What we do know is valuation of companies. We know how to value a company, right? People do that all the time. Be it an AI company, right? We do like a multiple of revenue or EBITDA, and that's how we determine the value of the company. And we're pretty good at, I shouldn't say pretty good at, but in the commercial space, there's ways to value intellectual property, right? And so those three areas are what kind of runs through my mind as, software products, valuing company, and valuing IP that we've sort of, I'll say, kind of figured out. And so applying some of those same techniques to trying to value AI is at least what's going through my mind. And so, Craig kind of hit it with valuing results, right? And I like to look at it as, the way the FAR is set up now, traditional defense contractor on a greater than $2 million award, you're going to be asking for, cost information, right? But is that the right way to get to valuing the capability or that result or whatever it is you're looking for? Ryan's answer, probably not, right? And so then you start looking at some of the FAR alternatives and you get into price analysis techniques for things like commercial. And certainly there's an argument that AI capabilities would fall into the definition of commercial, depending on how that's set up. And so then you start applying these price analysis techniques to this, and that's when you get into the exact conversation. What's the marketplace like? What are the capabilities that I'm getting? What's the value that I'm getting out of it? One of the things that constantly goes through my mind, and those that are on the phone that are much smarter with AI tech can correct me if I'm wrong, but I constantly view the idea of AI as a way to add efficiencies to whatever we're doing. We're either making things faster, we're saving money, or making more intelligent decisions, one of those three things. And those all have a value. And so if something is faster for me, there's a value that's worth. And if something's saving me money, that's a very obvious value that's worth. And certainly as a buyer, I wouldn't want to pay more than whatever it's saving me for a product. So that's one way to look at it. I don't love the cost method personally when it comes to AI, just from my initial brainstorm, like the idea that it costs you a lot of money to have to ingest data and make sense of it. I don't know that that's a good representation of what it's worth at the end of the day when there's an output. So I hang my hat along on the value, the capability, and trying to determine fair and reasonable price that way.
I do have a question on that, Ryan, because I feel you're part of the commercial item group, so you might have a propensity to understand how commercial systems work where it is on value. But I feel the government tends to do just about everything based on cost.
Sure.
The whole system is a big management accounting system, and so from that perspective, then what would you offer? Do you think that the industry will just get going initially? And I think this is what's happening initially, based on, hey, I'm going to buy this many hours of AI, and I guess the company would have to assert that, yeah, based on this project, this is how long it'll take, this is what we're doing, and therefore it's a fair cost. And maybe at the lower end of a contract, lower end value contract, like something below $1 million, it doesn't really matter. But if this starts to escalate into 20, 30, 40, $50 million contracts, then the pencil sharpeners come out and you have to really kind of scrutinize what the price cost is. What are your perspectives on what I just said there?
Yeah, I mean, I think there's definitely a culture, I'll say a culture of cost. I mean, it's just the traditional method of doing buying in the government. And traditionally, that was the model, right? You look at like 1960 and, GPS was a top secret military program, and DoD was the, creator of the coolest, newest technology that was happening in the world, right? And you fast forward to today, and that's just not the way it is. Sheldon, Diego are the developers of the coolest, newest technology, right? And we're trying to figure out a way to adapt and buy it. And so we have to sort of shift that culture, shift that mindset to being able to leverage what exists in the commercial marketplace. And a lot of that, I mean, I think there's authorities out there that exist. I mean, I shouldn't say I think, I know there are, which allow you to get to pricing as opposed to cost. And commercial is a big one, right? So the second something meets the definition of commercial, which I know is a big, long, convoluted definition, right? Then you're able to get to price analysis as opposed to cost analysis. There are other regulations that exist. So for those, and I would imagine that a lot of the AI companies meet this definition, but there's a definition of a non-traditional defense contractor, which effectively means you haven't had a fully CAS covered contract in the last year. And contracting officer has the authority to apply commercial acquisition procedures to their procurement just because of who they're doing business with, as opposed to it even meeting the definition of commercial or not. So and there's authorities out there, whether or not they're being used to their fullest and maximum practicability. I mean, that's just a cultural thing, but I think the regulations exist to allow the adaptation of price analysis in this area.
I actually really like how Ryan framed it. I mean, it's like the value at the end, and kind of working backwards is kind of how we approach it. So again, because we focus on operationalizing ML and AI, the main thing is, what are we operationalizing? What are you going to get out of it? And you played down your understanding of this, Ryan, in my opinion, because it really is that, right? It's optimization, it's next best decision making, and these things actually can be quite easily tied to, definitely in the commercial space, to a result, right? So if I can reduce fraud by 0.5%, and that saves me $10 million a day, which is actual use cases in banking. Now I have a framing of, okay, what's the cost of not doing it, right? Like, I now actually have like, there's no ROI on that. But I also have an understanding of, well, if it takes me $20 million a day to save $10 million a day, that makes no sense.
Absolutely.
And so, the work backwards method in analytics in particular, I think is a really, really good framing. It does become hard, I think, in kind of like very long-term projects inside, government, where, the time frame might be like 5 years, and like you're kind of out of like, hey, we're going to go build this out, this whole thing. And but I think there's a lot in government contract where this is actually pretty easy math. Right? Like you say, look, we understand that we're going to go, we need to reduce fraud, as Craig was mentioning, at, the SEC, and we can use this data analysis, and we believe that we can do this by X%. And if we do that, the benefit to the government is of Y, and therefore, we understand where our cost structure needs to be under. Working the other way, where it's just like purchase technology, and then figure out ROI at the end of the story is a losing proposition, in my opinion, and becomes very wasteful. It also delays kind of the whole process, because there's a discovery process there. So kind of like focusing on the use case, this is what needs to get done today, and then we can expand from there backwards. The math is not that hard.
Yeah, good point. I want to pull on Sheldon a little bit, since you've talked about the example with the car thinking, anyways, with your example earlier. So how do you value your services? Are you using a cost or a budget, or are you, how do you do price discovery with the customer?
It's a great question. And it parallels what Ryan and Diego said. It was only when we started translating this nebulous concept of explainability into improved prediction in a concrete case that the customer could wrap their heads around and say, okay, this is the ROI I'm getting, that the real commercial engagement happened. So for example, just like Diego mentioned fraud, we do a lot of work in manufacturing. What we're actually finding is that many companies, because of the risk, they're actually focusing on their internal processes first, that they can control, that they have a lot of data for before they put something out in the wild. And so the first question is, if I can detect a defective part 40% earlier in the workflow or the process, what does that mean to you economically? And we go through a very traditional pricing exercise of ROI on that point. But the second order questions that are coming out from that now are, what is the cost to you of an incorrect prediction? Or what is the cost when AI doesn't get it right? And that's where the ability to explain becomes so important, right? And there's two elements to this: the cost of getting it wrong, number one, and the benefits that explainability can help in really getting you that level of precision so you don't have a catastrophic use case. But the second one that we're now feeling is the regulatory impact of requiring transparency, right? We're seeing this in GDPR in Europe. We're seeing this now in Canada and the US. For certain critical systems to use AI, there's ramifications. I need to show a certain level of transparency. And so that's where, it becomes a question of, without this transparency, I can't use artificial intelligence in a significant way. And so what's the cost to me of not having it as an option? That's part of the analysis as well. Again, to anchor it in a concrete example, a few of our DoD clients are looking at using artificial intelligence for control systems, actually controlling flight and so forth. And they're better than traditional systems because of their ability to handle nonlinear cases and so forth. But they're now starting to ask the question, what are the requirements from DoD and the JAIC and so forth on being able to explain this decision? And if we don't get out in front of that, we're not going to be able to use the system. So it's also the cost of not doing it, as Diego mentioned. That's one of the driving factors as well.
I think that doubles into the test aspect. If you can't, I think the department is having a problem describing how they're going to test intelligent systems. Maybe the models are easier to test, but when something is doing, I guess, being tested like a 5-year-old, it actually achieves the goal, but it's not. They're not sure how it achieves the goal. That they don't know how to actually go and test the system. Is that what you're seeing?
Yes. Because sometimes AI will get the right decision, but for the wrong reasons. We developed a system to detect COVID about a year ago, and this was purely an open source effort. It's called COVIDnet. You can find it online. And in the early days, the system was looking to see if a human being was lying on a hospital bed. That would actually show up in the CT scan or the X-ray, and that would be a tell to the system that they were likely sick. And so it would get it right, or it would have a statistical reason to get it right, but that's not connected to why somebody has COVID. So being able to illuminate the reasoning is as important as, did you get the right answer? And we're seeing that from a testing perspective and the reliability that's required, especially in these critical systems. And there's an economic case to be made for that level of testing.
I want to, I was going to wonder, so, Sheldon's doing kind of like the really exciting kind of explainable stuff. Like there's kind of a whole boring aspect, which is kind of what we do, of the management of costs and, and infrastructure of actually deploying AI. And it really comes down to more IT governance, principles. How do I pass through security? How do I make sure the systems are secure? How do I make sure that they can be accredited? How do I make sure that the infrastructure costs don't fly out? How do I know where the models are being called and who's using them and it's the right people? And kind of, these are things that are kind of more attached to traditional software problems. At the end of the day, AI is different in the sense that it's data powered, but it is software. It's probabilistic instead of deterministic, but it's probabilistic software. And so it has a lot of the same conditions of IT governance that are required. And that goes into the costing, right? I need to be able to get into the system and I need to be able to run it. I need to make sure that, if I need, 4,000 machines, I know that that's the cost of those 4,000 machines, and I can control that cost as it goes up and down. And, am I using cloud computing, or do I need to buy racks of hardware to run it? And so this is, I say it's the boring part because but it's the stuff we do, in terms of kind of that IT governance, the who called what, when, and why, which is a layer that is completely on par with what Sheldon's talking about, but you need to take care of both when you're thinking out, it's not just about the consequences of if it goes wrong or not running, but how do we run this, right? How do we actually operationalize this and actually get that value?
Diego, there's a saying in golf, right? Drive for show, putt for dough. The boring stuff may not be that exciting, but to your point, it's actually where the problems lie. And, if you want to trade places with, I'm happy to consider it.
I guess, Ryan, anything to add to this conversation from your perspective?
I actually took down some interesting notes. So this is great. I love the idea of probability. Hadn't really thought about it. And as Sheldon was talking, I was thinking about more a risk matrix, chance of something not working, and then the impact if it doesn't work. Right. And I think that's all things that are worth considering as you're trying to determine that ultimate value at the end of the day. Diego mentioned, something that might save you $10 million. If there's a 50% chance it fails and that ruins your company and you go bankrupt, then, certainly something to think about as you're trying to value the capability in and of itself. So I like that.
Yeah, I feel like for a budgeting decision, I need I guess a simulation, a Monte Carlo simulation. It's like, is this thing worth this or that? You know, depending on some sort of simulation that you run.
Yeah. So there's actually a pretty very, very high level. If you think about a risk framework, right? There's kind of like three categories to a risk framework that you can think about. There is the what's called kind of reputational risk, right? Something goes wrong and it's bad, right? There's and that could be to an organization, being fined, to a government making a bad decision. There's a reputational risk. There's an operational risk, which is like directly tied to what Brian said. This goes wrong and I lose a ton of money, or I make the actual operational risk. Those two are kind of, think of them as on the left side. On the right side, there's something called strategic risk. What happens if I don't do it? So if you go way too hard on the protecting for the operational risk and the kind of like brand risk, or kind of like the like, you will restrict the ability to deliver something or innovate or get on it. And if you go too if you go too much, and that's the strategic risk, if you go too much towards the strategic risk pendulum, right, then you opening yourself up to operational and kind of like brand risk, brand being not like just kind of like reputational risk. So it's interesting. You have to like, and we've seen this in financial services. This actually happened quite a bit, where they use models in a bunch of different places. Something's gone wrong. They've tightened the hatches so much that now they've exposed themselves to strategic risk and not being able to take advantage of it. And so this is kind of like a framework or a pendulum that you kind of have to get right? Like, you can't go towards one side, you can't go towards the other. But that's one way of kind of framing kind of like the risk behind kind of machine learning efforts.
Yeah, thank you. I'm going to read one of the questions that we have in the chat, and then for anybody in the audience, if you want to post questions in the chat, we'll start to surface them. Here's a good one, though. Regarding the cost price analysis topic, what role do you see third-party financing solutions playing, and how we can deliver value to the government? And maybe I'll start with maybe Craig, if we can start with you. It seems like it might be something similar that Algorithmia is doing in that, but this is just financing.
I mean, I think, the thing that we're going to see, I think, for the near term, in terms of, the actual models and the innovation happening, we're going to see that coming out of consulting firms and small innovative businesses that are focused on specific niche areas, like, using computer vision to identify faces, or military equipment or things like that. I think, for the foreseeable future, like we see with, in Jake, you've got the award to Booz Allen, the $800 million contract for warfighter models. They're, hard at work building that. And I think that's what we're going to see. So I'm not sure from a third-party financing perspective of services that there's a path there. I mean, certainly it couldn't hurt, right? But because I think ultimately most AI development for the next, we'll call it next 3 to 7 years, is going to be really more services contract focused. I'm not sure we'll see much of that. Does that answer the question?
I think it does. Does anybody else have a comment there? Could you see a third-party financing solution provider come in to help augment maybe a company's capacity or capability? Yeah,
I mean, certainly, it's all, financing is key to survival for small startups. And I think probably, I mean, if you think about the BAA pipeline and the R&D pipeline, feds are spending all told over $1 billion in this coming budget year just on AI R&D. Yeah, I mean, it could make sense, right? But I don't see it. I'm thinking of it, and maybe this is a function of my history in the industry. I'm thinking of it as an aspect of, like lease financing for hardware and things of that nature. So I'm not seeing it from that perspective, but I think there are ways to get creative about juicing that AI ecosystem of companies and inventors that are out there to get them to build solutions for government. And financing is definitely going to be a part of that.
Yeah, interesting innovations will have to happen. Given the conversation we have, and in terms of thinking about the framework and explaining or assessing value of AI, I put myself in the position of, I guess, the government trying to come up with a budget, for something. And because there's so much change in this sector right now, it's probably hard to put, maybe that's why the services contracts are the starting point, because maybe the risk it's easier to bound that risk. But just given that backdrop, I guess, Ryan, I'll start with you. What would you advise government entities? How would you advise them to think about AI? How would you even advise them to think about a budget?
Yeah, it's certainly not an easy question. I think, I kind of looked through the list of invitees or registrants on today's call, and to no surprise, it was mostly industry and AI companies. And, to me, that kind of indicates that we're, from a buyer standpoint, ahead of the narrative a bit, right? Where you have a whole bunch of people on the phone that want to know how to price their product, right? And there's not a whole lot of people on the phone that are buying yet. And I think it's great. It's great that we can have that collective narrative and try to figure out the right answer to what something's worth, collectively, as this becomes a more prevalent technology. From just the standpoint, I think one of the bigger hurdles that we need to figure out, and it's been racking my brain, and it dovetails into software too, is sort of the product versus service conversation. Like, are we actually buying a service, or are we buying a product, or are we buying capability, or how do you want to frame that? It matters when you're talking about the commercial definition. It matters when you're talking about price analysis. And I think the easy sort of dichotomy and the easy example I can lay out is, agile software development. You do things set up in sprints. The preferred method of contracting is modular. So you're talking, 6-month option years where 6-month options where you want someone to do this level of effort, and you're basically doing a cost-based price analysis where that employee should be getting this much dollars per hour, et cetera, et cetera. But at the end of the day, if you don't have usable capability, what's that worth, right? And to try to balance those two topics is very difficult. The nice part about the modular contracting is you end up kind of incentivizing performance, because if they don't do something in 6 months, then they probably won't get the next option year. But it's really difficult to be able to, in advance, determine value of what that sprint might be, and put that contract at a certain price that is reflective of that, without really a previous sprint or knowing what's going to be delivered at the end. So when you think about it from a service perspective, I think there's a lot of, I don't say nuances or challenges there on trying to achieve paying for value while also knowing that you're actually buying hours.
Mm-hmm. Mm-hmm. I guess from Sheldon, anything to add to some of those comments?
I think Ryan's clarification between product and service is one that we feel significantly. We've sold product to organizations that are far enough along the machine learning journey where there's immediate value and they can quantify it. But they're in the minority, I would say. Where we have the most success is when we're selling an outcome and selling an efficiency, which is both product and services. I think most AI companies are struggling with the question of, are we a product company or are we an AI consulting company? And given the adolescence, let's say, of artificial intelligence in general, you have to provide some of that service capability to elevate your product. So right now it's both. It's a necessary, I won't say evil, it's just a necessary byproduct of trying to drive the innovation so they see those outcomes. I'd be curious as to what Diego and Craig have to say on that.
Yeah, I generally, again, from our perspective, it's much more infrastructure, and software related. So a lot of times the services is just to get there faster, right? Like, we know what we're doing. We've done it before, we can come in, we can help. And so it's software plus services, and the services are just an enabler of making sure that the software gets to the ROI that you want. The other, I think Ryan mentioned, I agree a lot with Ryan today. The modular piece really, I think, is important. So, this is just experience that I've had. So, in different, like, if you have a project that's long, right? Like, and it's, you have these very long time frames and they're not broken up, like people change in government. Right. I mean, like there's literally like, I mean, it's by design, right? There's change of guard and change of priorities and change of projects. I think even DARPA's faster, like it's like every 2 years. And so these programs, like if you don't modularize it and kind of like have a general North Star, but kind of like break them down into small pieces that you can execute on immediately and provide value, it actually becomes really hard, even if all the money in the world was available. Right? Like it becomes really hard because things change over time and at the speed that the AI and machine learning world is moving, right? Like a 4-year, a 4-year program, we're going to be light years ahead next year. Like the technology is going to change and stuff like that. And so the modularizing, like, I think finding, like getting really concrete on use cases, getting really concrete on the ROI of that use case, and driving to delivery of that use case as quickly as possible with a combination of product and service, and building off of that success is the formula that works. It works in enterprise. There's no reason why it wouldn't work for government. The only problem that I see here, and again, I'm not an expert in this, is that in government, you need to go ask for a bunch of budget up front. Like there's, and you need to get that all in and it needs to get approved. And so like, there's not this like way of kind of like coming in halfway through the year and saying, okay, we're going to assign this to this project, get a result, then increase it. Like that previous planning at a high level, on a 2-year analysis or a 3-year analysis becomes really hard to combine the agility and the ability to execute with kind of like the budgeting process.
I would add to that, and I agree, Diego. A model we've seen work very effectively is almost an ideation POC or project, right? That you iterate on. It's very clear ROI. It's quantifiable. There's a lot of data, and the effect that we see that has is, yes, it'll show a quick win, but it almost socializes the organization to the AI workflow questions that they need to start thinking about long term. Right, that'll surface a question in the organization of how do you think about data governance? How do you think about collection? How do you think about privacy of data? We feel this is a Canadian company with ITAR restrictions and such. And so it leads to a broader discussion of what's our AI strategy, and you can help them be a thought leader in that respect. But to your point, the challenge is overlaying that with a longer term budgeting process. We've had some success with almost a gating mechanism. There's an additional ideation POC. Hey, if we show these results, which we agree upon up front, we're going to move to the second one and the third one. And in combination, that gets you up, that large number that you're trying to ask for up front.
I think it's interesting that what you say, Sheldon, because and just in my work, I've been dealing with a couple of organizations trying to get their arms around their own digital transformation. And at least for the Navy organization, there's a lot of questions left unanswered as to what certain, at certain levels of organization, what they need to do. So I'd be curious to hear from any of you, the services product model. In that, I believe the services piece is going to have to remain around for some time because the receiving government entity just doesn't have the capacity, the know-how, the skill sets to actually operationalize, the software product. I mean, they're still learning data science. Like they just don't have it. Any comments to what I just said?
The services are a great thing. They're accelerators. Like we have to, like, this is not a, like, especially if you tie it to results, there's just a high motivation on the vendor side to make this a huge success. When you're saying, hey, we want to get to this is what the objective is, and it's on you to succeed here, and we're going to give you these tools, but you bring in your know-how, your software, your services, your people, and if you get to this milestone, we get to this next thing, and then we get to this next thing, and like there's a ladder there. Like that is hugely motivating. I mean, like, I can't speak for Sheldon, but I'll tell you for my company, we would jump into that deal in a second because we know we can do success. We know we can be successful, and we know what it takes to do it.
And it's also the learnings that you get by being in combat with the client and learning about their business, right? It's we're the AI experts. We're not the experts at, sonar recognition or signal analysis for this particular use case. And to your point, Alan, like the service is going to be there for a while. The analogy I sometimes give, people that are not in our field is imagine the internet in the early 90s when only a small group of niche individuals knew that, these numbers flying over telephone wires were going to transform things. But everybody else was just, what is this? What's going on? How does this work? Like, that's where we are with artificial intelligence. And it's an accelerator. I completely agree, Diego. Like, if you can drive your client to success, why not do the services? You'd be, unreasonable not to, or outsource it to somebody who's going to get the learnings.
Yeah, and I think there's a way to frame it from a buyer's perspective, where instead of I want your company to go spend 2 years trying to figure this out, and you're paying for, no kidding, a level of effort, to sort of do kind of what Diego said and have this laddered approach to capability, and achieve this, and here's what you're going to get for that, and achieve this, and here's what you're going to get for that. It sort of better defines planned outcomes. Because at the end of the day, I think the downside with what I had started off by saying is you could end up at that 2 years, you paid however much it cost, and you have no capability, right? And so that's the nervous part of being a buyer in that situation, where you're just putting someone on contract for hours.
Yeah. So maybe that translates into how are these projects and programs managed, and in a way so that I feel like it's on the customers. The onus is on the customer to get value out of their contract. So how, I guess from a service provider's perspective, how do you enable that? But from the government perspective, they do have to put in the mechanism from which to realize that value.
There's no line item for be innovative, in a or whatever it is, right?
Exactly. Yeah. Here is one question, though. I'm going to read this out. If the government is going to constrain AI solutions to be transparent and explainable, does this preclude all neural network solutions? Or is the government going to require causal experimentation to make outcomes explainable?
Anybody I can start. That's obviously the problem we're trying to solve, right? Through our technology is offer explanations for neural networks. And even the explanation, though, is a statistical explanation. That's the important thing to understand. That's the whole challenge with neural networks. They're so fantastically complex that, much like the human brain, we don't know why they do certain things. So the question we're grappling with in the context of legislation and regulatory requirements is, what does it mean to explain? What are you actually explaining, and to whom? And under what circumstances are you obliged to give that explanation? All right. And there's various drafts of legislation. Some say only when it's a critical decision that affects a human being in some way. The legislation we have in Canada right now is very restrictive, and it's not yet a law, which is anytime an automated decision is made, which would make AI completely untenable. So we're working through what that means. And most people feel we'll get to a middle ground where you are giving a reasonable explanation for a critical decision, because this technology is just too powerful not to be used in many circumstances.
That's a good point, a good observation. I think about adoption generally in the community. We're going to see, augmented intelligence before we see artificial intelligence. I think, the concept of human in the loop is just going to remain, part of the picture, going forward. And the other aspects of it, explainability and the statistical model that says, here's what went into making it a decision, here are the weights and the biases, is part of the picture, but not part of the total trust picture. And just kind of like go back to maybe slide number 1 in today's meeting, right, is that there's not going to be any adoption of AI unless there's trust of the AI. And that trust comes from several different areas. Explainability, statistical modeling of the decision is important, but also what we call interpretability, which is, what's the context for this model? How was it used? How was it created? Who is involved, right? Who else is trusting this model? When you've got a set of operators making decisions, in a combat type of scenario, sometimes you don't have time to look at the statistical weights and biases. You just know that, hey, Jane uses this one, so Joe's going to use it too. And you layer on top of that the accountability of model usage after the fact. If you can go back in after the fact and say, on this date, this app made this decision, you call this API that uses this model, that uses this data to make a fraud decision or a loan decision or what have you, you're going to get a higher level of trust, in the output there. And I think those three things kind of come together are going to have to come together before we're going to see, large scale adoption of AI in many contexts.
So that's a good framework. I think we have time for maybe just one more question here, and let me read it out. And for those of the panelists, it's in the Q&A box. For non-commercial items, DoD generally pays cost plus or a fixed price. That's a guess at cost plus. They can't do cost benefit analysis because they can't quantify the benefit the way you would say for fraud detection. So the DoD doesn't really know the value of readiness or can't monetize the improvement provided by some new ML tool. So will the providers of ML tech be willing to participate in this nebulous market? I feel like you already are, but what are your comments?
I was going to say, I think I can tackle that real quick and then maybe ping the next question real quick as well too, right? Because the cost of building AI ML, a lot of it is the data, the training, the development, the model building, the science, the math. You're going to see more providers of ML technology participating in the BAA pipeline, the R&D pipeline. You're going to see, I think, more contracts led for services like we talked about to make creative things, because most small companies are not willing to take the risk on the government buying or not buying a product they may build on spec. And a lot of that is because of the effort and the complexity. It's like 90%, right? Develop, train, get it ready to go. 10% push the button and make it happen. But it's that 10% that makes all the difference. If you don't operationalize all that investment, you're not really getting anything out of it. So I think ML technology providers will be able to participate on the R&D side more than in the treating it like commercial products. And that's going to impact how this market grows in the federal space.
Any other comments from the others, Ryan or Sheldon?
Just a blanket easy one, but I'd challenge, and I'm not saying that everything that's AI is commercial, but as far as the very framework of the question itself, GFARS 239 talks about how IT in general should be considered commercial, if not go to your HCA. So it's pretty well laid out, the expectations in my mind, congressional intent and where we have with US code. So I'd have a tough time, seeing some of these, maybe it's specific military unique, but you're talking about just creating artificial intelligence that can be adapted for both military and non-military capability. So I would like to see examples that maybe wouldn't be commercial and are forced in the cost type pipeline, but that's it for me.
I mean, smart chatbots are one thing, right? And targeting systems that pick where to drop an artillery shell are another, right?
Sure. Yeah.
I think the dichotomy there. Yeah.
I'd agree.
So I'm going to end it right here. Any parting shots? Because I have just kind of parting words here.
No,
well,
go ahead.
I just really wanted to thank Sheldon and Craig and Ryan for being part of the panel. For all the audience, what will happen is this session is recorded and Charlie is going to be sending out to everyone essentially the recording so that you can have it. And I believe anybody else who's registered who hasn't attended will get that recording. Really appreciate you being part of this panel. It was super exciting and learned a lot just by hearing this conversation. And hopefully we can continue to have this conversation and help both the company side as well as the government side figure out, how do we meet in the middle here and cause this AI revolution to happen. Thank you again.
Thank you.
Thank you.
Bye.